Kia ora Year 12 and welcome to the first video I'm going to make for 2019. I thought I'd start out with doing some revision of vectors from AS. So this is from an AS paper, not an A-level paper, because we're not ready for that yet, and it's an old question from back in 2014. But I quite like it because it goes over some of the big vector ideas. So you're going to have to get used to some very bad drawings this year, and the first one goes like this. We've got 3 points, and the points are O, A, and B. And we're given, so O is the origin, we're given the vector from the origin to point A, and then the vector from the origin to point B. So I'm going to draw some axes. I know that I could do this nicely with software, but I'm usually in a big hurry when I do these, so you'll just probably get used to it. This is point A, this is the origin. So this is the vector going from O to A. This is point B, so this is the vector going from O to B. And we know that eventually we're going to have to find the vector that goes between those 2 points, right? And we're going to write that as AB, going from A to B. So in this question we've got 3 things. The first thing we have to do is find the values of P for which OA is perpendicular to OB, because we've got a number in here P that we don't know, and as P changes, point A will move around and point B will move around as well. So we want to figure out what value of P is going to make those vectors be perpendicular to each other. So the key idea here is that the dot product OA dot OB must equal 0 to be, for those 2 things to be perpendicular. Then the next thing we're going to look at is the big idea of magnitude, and we're going to call the magnitude of OA and OB A and B. We're going to figure out a value of P that makes the magnitude squared of the second one twice the magnitude squared of the first one. Lastly, we're going to find a unit vector, and a unit vector this vector has to go in the direction of AB. A unit vector has magnitude of 1. So this question is also going to be about the magnitude. Okay, so let's start off by first of all remembering that if we've got a vector, so here's OA, and here's my bit of paper. So OA is written in IJK form at the moment. But it's usually easier to work with column form, which is 1, 3, and P. We can do the same thing for OB. It's -7I and so on. So just copy that out from the question. And that can be changed into column form as 7, -7, 1 minus P, and P. Right, so for perpendicular vectors, we require the dot product to be 0. So for OA and OB to be perpendicular, we need to have OA dot OB equals 0, right? Really important to write down your reasoning, even if it's brief. So what's OA dot OB? Well, we've got 1, 3, and P dot -7, 1 minus P, and P. So that's -7 plus 3 times 1 minus P plus P squared, and that has to equal 0. So we're going to have a little quadratic to solve. So -7 plus 3 minus 3P plus P squared equals 0. Cleaning that up, we get P squared minus 3P minus 4 is 0. Quickly solving that gives me P minus 4 times P, plus 1. So P equals 4, or P equals -1. So that's the first part done. Okay, so big revision idea in there, dot product. If you're worried about that and you can't remember it, ask me in class and I'll give you some revision stuff on it. Now, the next part is where we have to do the magnitude. Okay, so I'm going to skim quickly back up to the question. So we're asked to find the value, wrong pen. Find the value, still the wrong pen. Find the value of P for which B squared is equal to 2A squared. Now it's only a 2 marker, so you probably know it's not going to be too bad. Right, let's write down the magnitude of these things. Right, so what have we got? Well, magnitude OA is what we're going to call little a. And we get the magnitude by applying a 3D version of Pythagoras. So it's 1 squared plus 3 squared plus p squared. That works out to be the square root of p squared plus 10. And so a squared is equal to p squared plus 10. Right, the next one. What's the magnitude of OB? Well, we do the same thing. We take each component of that vector and we square it like this. Be careful when you're expanding that middle quadratic term. Don't make any silly little mistakes. So we've got 50 minus 2p plus 2p squared. So that's b. b squared is 2p squared minus 2p plus 50. Now we need to find the value of p such that b squared is equal to 2a squared. This stops being a quadratic in a moment because we've got 2p squared on each side. So finally we get down to a final value of p is equal to 15. Right, now the last bit is where we have to find a unit vector in the direction of AB. So let's plonk A and B on this picture somewhere, anywhere. Let's put A here this time. Right, so there's A, and here's B. I don't know, we'll put B there, right? So this is the origin, but this time we're interested in finding a vector in the direction of AB, and we've given a specific value of P. So that's going to make it much easier because we've pinned down the particular value of A and B. So we're going to find, let's first of all find the vector for each of OA and OB when P is equal to -8. So what was OA? OA was 1, 3, and P. So now that we've got that value, it's 1, 3, and -8. What was OB? Well, OB was -7, 1 minus P, and P. So here, that works out to be -7, right? 1 minus -8 and -8. Now you're probably thinking, why is she writing that down? Well, I'm doing that because in AS and A level, you know that you really want to avoid tiny little mistakes. Okay, so always better to put full working to reduce the chances of that happening. So there's OB. But we're not interested in those two separate vectors. We now want to find the one that joins up those 2 points like that. So to do that, we go the vector from A to B is equal to OB minus OA. Now doing this should feel really, really easy after AS. If it doesn't, come and talk to me and don't wait till term 3 to do it. Okay, so the vector that goes between A and B or through those 2 points can be found very easily. And it's this. So it's going to be -7, 9, -8. Take away 1, 3, and -8. Giving me -8, 6, and 0. So if we look back up to the bad graph, what we're trying to do is to find, we've got this whole vector, well, we've got this distance between A and B we can find now, right? We can do that by looking at the magnitude of my vector AB. But we're interested in a vector that's only 1 unit long, but going in that same direction. Okay, so we're going to figure out the magnitude of AB, and it turns out to be a really nice 10, right? So -8 squared plus 6 squared plus 0 squared, which is the square root of 100, which is 10 units long. So going back to my bad graph, that whole of that yellow line has got a length of 10. Now we don't want one with a length of 10. We want a vector in that direction, but with a length of 1. So all we've got to do now is to divide it by, oh, what's happened there? Okay, we're down to here. I'm just going to go to a blank page. So AB, the magnitude of AB we got was 10. So the unit vector has to be 1/10 that length. 1/10 of this vector here, -8, 6, and 0. So it's okay to leave it like that, but it's a bit dodgy. It's much nicer to write it in a couple of other ways. So -4/5, 3/5, and 0. So that's one way. And if you check that vector, you'll find that it's got a magnitude of 1. The other way that we sometimes write them is if the question started out in IJK form, we might chuck it back into IJK form. So it's going to be -4/5 I plus 3/5 J plus 0K, or you could leave the K off. It's probably best to put it in. Or you could write it as this, 1/10 of -8I plus 6J plus 0K. So I think my two favourite ways in there are either to write it like that or to write it like that, but show for working in either case. All right, thank you for your patience. This video was much longer than my usual ones, but it was a little bit slower than usual as well. So if you have found this way too easy, you'll quickly learn to skip through the easy bits and just use the fast forward button, or even just don't bother to watch it all. Thanks for watching.